Welcome everyone to this week's IPLD sync meeting. It's April the 11th, 2022. And as every 2 weeks, we go over the stuff that people have worked on and then go over any discussions there might be or agenda items. So I'm sorry for the delay. I had technical difficulties, but now everything should be fine. I should also perhaps put the meeting notes into the chat room. I guess should we start with announcements perhaps this time? Perhaps Eric?
Yep, okay, that's me. I'm also going to keep this very short because I have the great fortune of being rather sick at the moment, so my voice might not. Anyway, there might be some changes in some of the familiar faces you see around here and the frequency at which you see them. As for me, I'm going on a vacation for a while, and I might still be in and out around here, but probably with less frequency for a couple of moons to follow. We've also got one fewer MV Dan in regular attendance. He's accepted a new full-time position in another organization, and we're really going to miss him and wishing him luck over in that new thing. The project will continue. There will still be lots of other people to triage things. We'll figure it out. And that's all my voice can handle, so talk to you later.
Thanks, Eric, for the update. So now we go to the regular stuff that we usually talk about. So so in this meeting notes, I don't see any updates from anyone, which is interesting because this never happened before.
I have some updates to or things to share with people if we have time, but yeah, don't want to eat up all the time.
Yeah, so I also don't have an update really from my side. So I guess I just Adit, I think we should get started and then.
Okay, cool. Yeah. All right, well, let's start. All right, so I guess I have two things. So one is I mentioned this last week. I hacked together some stuff for IPLD plus BitTorrent things, like a codec for Ben code and an ADL for files. They exist and work, and I can do things like load pictures over gateways by making a minor tweak to the gateways to allow them to be like, is your node a byte? Is your node bytes? If so, that thing probably will render as a file, and then do that. And so that means like any ADL that outputs bytes would then be able to turn into a file. So I'd like to see some of that work get pushed through, and that's kind of like a pretty cool step in the direction of like UnixFS equals less special, which is awesome because like a lot of people have a lot of problems with UnixFS. All right, the next thing is like, oh, so this BitTorrent stuff and whatever, this seems cool and all, but like, you have to write the codec and you have to do it in all the languages. And like, Dean, are you going to feel sufficiently motivated to write this in JavaScript? And the answer is no. But I hear that people are really into write ones that run everywhere, which may or may not be the cure to everything or a way to make everything slightly less performant all the time. And that is WebAssembly. And so I have written a codec and ADL in WebAssembly that also get called from Go, or can get called from Go. And so you can then use those things, and I can do things like let's share my screen. I can do things like load koala pictures over gateways where like, this is a B encoded CID for an info hash. This is like literally just a BitTorrent info hash.
And that's a selector? What?
And this is a selector. This selector is, you know what? This is actually much easier. I can see, because Go IPFS has these things. I can do like this. This is the selector, represented as DAG.json. It is the please interpret me as a BitTorrent file, and then just like grab the thing, match on it, and just grab that node for me, please. And so this is saying, take this be encoded thing, please be interpret me as a BitTorrent file, and then render me. And it's like, oh, hey, you're bytes. And then renders it at bytes. How does it know it's a JPEG? Same way everything else knows everything's a JPEG. They sniff the first few bytes and like, maybe it looks like a JPEG, which is how the gateways work kind of already. And if you wanted to make that more annoying, you could do like, or handle all the edge cases, you could do things like put in the download file name to end in .jpeg, and then it would do the sniffing like that too. Now, again, the codec, for those not fluent in multi-formats, this is the thing that says bencode, or bencode. This is written in WASM. There's a Go one too, but this is WebAssembly. And the codec, the ADL thing in here is also WebAssembly. And this was done by, let me not going to be perfect because I didn't have time to quite finish this, but okay. Yeah, so that's not quite right, but basically the way this was done was first I made a new codec. Basically, Eric has some great docs on this, but we have no codecs that are complete and fitted to the IPLD data model, where complete means it represents all the things the data model represents, and fitted means there is only one way to take your codec thing and like put it in the data model, and vice versa. We don't have one of these. DAG Seaboard doesn't do it, DAG.json doesn't do it, DAG PB definitely doesn't do it. So I made a new one, mostly yoinked from Michael's simple DAG, but made slightly different. This is the motivation. Is it perfect? I don't know. Called it whack. I need a better name. It's the WebAssembly codec. The idea is I don't want to keep crossing the boundary between WebAssembly and the host. Maybe when the host is Rust, it's cheap. When the host is Go, my understanding is it's not cheap. A lot of these things come with caveats. My first line of Rust code was last Sunday, so who knows? Yeah, we can look at, I can link to the spec and we can talk about that if people are interested. There are things to still work on. Mostly, there may be better ways to optimize encoding and decoding. I haven't specified floats, mostly because the thing I stole from Simple DAG had not really described floats. And I think in general, the IPLD model is a little sketchy on floats. So we might want to like get that described so that it can then be accurately represented in the codec. And then people seem generally grumpy about parts of the data model. And because I am faithfully executing the data model, that means there is some grumpiness there. I think we can use this as like an opportunity to like flesh that out and figure out what our options are, if any, to progress. But like, because there's like a thing to maybe represent or work with, it may make it like a little more concrete for us. For those less familiar, some of the common points of grumpiness, aside from what is a float, include what is a string and what is a map key. Yeah, so there is a whack implementation in Go and in Rust. I haven't written the encode format, just decode, because I didn't need encode in order to show the koala. Yeah. I sort of YOLO'd the calling conventions. Again, first line of Rust code like last Sunday. But basically, you allocate for codecs, decode, you just allocate some space. you load the bytes into the space, you call it, and then you return the data that's returned from the WebAssembly call is just a WAC encoded thing, which means I can then, because it is fitted and complete, I can then turn it back into the data model. So that's the point of this. So I don't have to keep crossing boundaries. Yeah, there are some TBD things like better calling conventions, figuring out how to return errors, and how people do this in WebAssembly. ADLs are similar. Encode the node as whatever the node is, string, byte, something, a map. Encode that thing in as WAC, pass it into WebAssembly with the create ADL thing, and then just call functions on that pointer. For instance, read into this buffer for me, or seek. Seek into the ADL, into the bytes in the ADL somewhere. I've only done this for the bytes node, but we could do the same thing for lists and maps and things like that. And that is all. There's a lot more I could dive into, but yeah, I don't want to eat everyone's time, so I will let questions come in and then use that to figure out how much time to allocate.
Thanks. That's really super cool. Like that's like I can speak for myself that it's something that I wanted to build for ages. So that's super cool.
Yeah, it sort of does the thing almost, right?
Yeah.
Yeah, I think the idea here, like what I'm trying to get to, there's one other thing that I have in my demo for the BitTorrent codec, which is sort of the what's next. And I think or what's it take to make this thing like great? And I think that one of this is like making the codecs and ADLs more portable, which is the WebAssembly thing. But the other is like being able to move around arbitrarily sized blocks of data. The problem is like you have to cut the line somewhere for what is the block limit in your program in order to make sure your memory doesn't blow up and your disk space doesn't blow up and things like that as you wait for the data to be downloaded so you can verify it. And whatever your application chooses, the magic number is going to be wrong for someone's definition of wrong, right? You're going to say 2 megs, and then the IoT people are going to be like, what are you doing? You're killing my RAM. And you're going to choose 2 megs, and the people are going to be like, what are you doing? It should have been 80 megs. It's so inefficient. And there's really no winning. So in order to be able to be backwards compatible and really have like use IPLD as like the connector of all the DAGs, you need to be able to be backwards compatible with those formats, which means being able to figure out how to handle the large blocks. So there are some proposals for that on the networking side that I would like to work on as the year moves on. But the IPLD side, in a sense, was easier. So I figured I would start with those things before the networking things. But yeah, I'd like to be able to describe like a lot of these things. It was sort of I had to YOLO a convention. So like input requested, I will get more repos up and link more things. But this was just sort of to motivate the conversation, I guess.
I am deeply impressed with how you just showed us the koala. I also got the giggles off camera when you said I didn't need feature X in order to show us the koala. That use of selectors is amazing. Although I also hope that we see it work with other signaling mechanisms in the future. I know that's later. You got an interface for big bytes where you're doing an ad hoc seek API, right? So I'm guessing this probably isn't being zero copy, which, okay, I guess that's probably a really ridiculously high bar to shoot for crossing languages. So sometimes you could have a read request and it will like cross 2 internal blocks because you have no way to align. Fair enough. So you did big bytes ADLs. Did you try doing big maps or big list yet, or is that like?
No, I just did that
Okay.
one because I didn't have yeah, I didn't have time / a thing to point at to do another thing. But yeah, I definitely think we could do that. There are other things that are worth considering, like, and people who know things about like WebAssembly and or Rust probably could help here, in the sense that maybe, for example, instead of calling as I do the reads and you move along through, maybe you don't want to have to get the full block from the block store every time. You probably want to do like cache some of the blocks in the WASM code for a little while. Maybe you want to like cache a few blocks around instead of needing to go back to the, across the boundary and go into the block store in the host to get the bytes and reconvert through WAC and all of that. Right now it doesn't, but I could see why that might be useful. There was another version of, and I think this is part of like trying to figure out what to do with this. There was a version of the WAC thing that I had talked about with Steven, where instead of it looking like this really simple thing, it looked a little more like the C memory layout of if you had tried to implement the any node, like the basic any node in Rust. And then you sort of build your any node in Rust, and then you just say the C representation of these bytes, that is the WAC codec. And maybe that's a good idea. I don't know. This certainly seemed easier for someone who was unfamiliar, so I did that one.
This is a comment for like or for like zero copy for WebAssembly. At least from coming from the host to like into WebAssembly, there is a spec I think getting worked on, but it's not likely going to land for WebAssembly. So you do have to copy from the host to WebAssembly, and then internally WebAssembly can do zero copy stuff, but yeah.
Yeah, I think so. A lot of people, and so I think this is pretty cool. A lot of people get very excited and they're like, "Oh, cool! You have WebAssembly codecs. Have you considered loading everything by CIDs everywhere and like having CIDs as codecs and ADLs and attaching them to all your data?" And to that, I would say, I agree. That sounds cool, but like as I guess was just pointed out, the WebAssembly specs are like kind of new and kind of bare bones. And whatever we're going to write as like the IPLD calling convention on top of that is also going to be kind of new and kind of bare bones. And I think giving some time for that to like mature, right? So that we're starting to, we can start to write more of these things and we can reuse them in more environments. Doesn't necessarily mean we jump like right away to network load everything everywhere, because then we sort of if we're not careful, we may have locked ourselves into whatever terrible IPLD calling convention that I made up without understanding Rust. So like, I think that's kind of the order of operations, as we get to like explore a little bit here how to do this better. And then as we learn more about that, we can start to be like, oh, okay, this is cool. Now we get to start answering some of the hard questions, like, how do I move these things around? How much gas do they cost? I tried turning on gas cost just to see if it would work. And I was like, the mechanism I used for determining gas costs was I kept increasing the number until it stopped failing. But like, that's not really meaningful, right? I wrote it for one codec. I wrote it for one codec and one ADL. That's not, that doesn't help you figure out what the numbers should be for resource consumption.
Parity Tech has a lot of work into gas costs for WebAssembly, so it might be useful to talk to about that.
Yeah, that makes sense. I also suspect that Steven and the folks working on the FVM probably have some notion of gas costs there as well, and are also thinking about some of the IPLD stuff, including like, what does it mean to call into the host for how they do blocks? they're doing it a little differently. I think they're keeping all of the data in the host, I think, as opposed to sort of moving it into as opposed to moving it so much through the WebAssembly stuff. But I suspect they have to worry about those too. Yeah.
So as far as I understand, when the rubber meets the road, it's actually still really primitive, just globally. Nobody's figured out how to solve this. It's basically the halting problem, but like practically as insolvable as well. My best understanding is that, especially as long as we ever live with algorithms where the performance is data dependent, which also is just like, yes, that describes reality in almost all cases, right? I think the best thing people have figured out for like blockchains in general, where they have a strong incentive to figure this out, is pre-perform the computation and measure how expensive it was, and then ask the network to deal with that cost. And then if you have operations that need to be performed on the networked computation, on the publicly replayed computation, that turn out to be data dependent on some state that changed by the time the network gets along to replaying the computation, and that changed the cost, then as far as I know, that like basically provokes a whoops-a-daisy situation. And like maybe your computation just fails to apply because you now underestimated the gas, or you waste gas because you overestimated it. So if you don't solve that immediately today, you're still in good company, and this is still progress.
Yeah, this is why I feel like we get to like solve a bunch of these problems, which is like, I don't want to write all my codecs in all the languages, but I still want people to be able to do stuff. Like there's some folks who are working on sort of a better version of IPFS gateways, where instead of I go to a machine and then ask it to please like send me a file, instead I have a little like JavaScript widget that fetches car files or fetches IPLD blocks from one or more sources and then reconstructs them into the data I'm supposed to see with like service workers, which both means the data is verifiable, but also that I can get it from more places. But the only way to do the verifiable thing is to like understand the IPLD pieces, right? So if I wanted that to work with, you know, the BitTorrent ADL, then it means that the JavaScript code needs to understand that too. And so like, I don't want to be the only one doing this, right? I suspect there's lots of file formats out there. There's Git has a file format, BitTorrent has a file format. Most of the like data storage blockchain-y things have data formats. If you're Storage or Sia or Arweave, there's some blockchain transaction somewhere that has a link to all the pieces that you're supposed to be verifying. Right, those are all data formats that you could just represent as files. And you could be like, yep, they're all just IPLD things. They turn into files with ADLs. We can move them all around the same way. Content identifiers, they're good. Don't use location or system identifiers.
So Adon, good to see you. One question I had, okay. Can you chain them? Can you do like for the koala, basically, let's say you want to also encrypt it or decrypt it, and from like you're loading it from the WASM, it's supposed to be a JPEG. You're selecting as a JPEG, and by the way, once it's decrypted, it should be displayed as a JPEG.
So I think I'll separate that into two pieces. Yes, you can do chaining in the sense that if we pretend for the sake of argument that I did what Eric said and I had also built one of these for large maps instead of just large bytes, I could traverse through like nested layers of large maps, or I could traverse through a nested layer, large maps into large bytes. Encryption is trickier because I have to find a way to like thread the keys in the right place.
Yeah.
At the moment, as you saw, like the way that I'm putting the key, I'm putting data in is through like the way I'm signaling is using the selectors. We don't have a signaling. This is, I think, where Eric was getting with like, we should have more signaling mechanisms. If there's a signaling mechanism I could throw in there, that was like, oh, by the way, use this decryption key. AES decrypt this thing. I don't see why that would work fine.
I think at least from Juan's early libraries, he basically used it as an anchor ID, and you grab it from the URL. So I can see the problem that the schema of the ADL actually, like, you pass through, you can't necessarily put that in those bytes, but maybe you pull it from either the JavaScript pulls it from the anchor ID when you display it. So
yeah, so if I could go through the final sets of things to the end, right? If the only thing I need decrypting is like the file at the end, I could definitely see building a program where like you pass in the CID and the selector and it gets you the large bytes, and then you put like, sort of hashtag decryption key, and then it decrypts that. But if I need to like decrypt the links along the way or something, then
gotcha. Yeah,
then I would need to do things like have another signaling mechanism, right? I mean, I guess I could propose something maybe wacky, like have a selector that is, instead of interpret as, it's like decrypt as, and then it gives you like a key and like an algorithm for doing so. I don't know if that's a good idea, given that people like passing selectors around on the wire, and you tend to want to keep the decryption keys like on your machine. But you could see such a thing.
Yeah, but you wouldn't pass. Yeah. You at least that hashtag anchor ID isn't supposed to be passed. Browsers aren't supposed to be pushing it through to the.
Yeah, so if you keep it afterwards, like outside of the selector, and you keep the anchor IDs out there, then this is fine. The question's like, what happens when you want to? And I think it's somewhat it affects like what user stories you're trying to do. Of like, do you need to do the decryption stuff along the way? For example, if I'm trying to follow a graph that has encrypted links in the middle, I either have to do it like bit by bit, sort of bit swap style, where I walk the graph locally, or I have to ask you to like oversend me bytes, because you don't really know which ones to send me yet, so that I can then get them back. Or you need to have a particular type of encryption scheme where like I'm willing to let you know the full structure of the graph, but not what any of the bytes are in the graph. And as with almost anything that's like access related, whether it's encryption or ACLs, like everyone has their own opinion on what is like the best way to do so. Like, you're sending too much data, but you're protecting it too much and it's inefficient and whatever. But there
was an interesting Apple and Google working on, and I'll put it into the chat, this proposal through IETF about a mailbox for sharing, I guess they're calling it secure credential transfer. And so where like very similar to the hashtag ID or the anchor ID is basically being used as for the decryption mechanism. And so I think this is just where my head was at today. Cool.
Cool. Yeah, I'll take a look at it. Quick little piece of glue content to zoom back out a little bit also and like frame. There's different kinds of composition. So when you have ADL code, of course, it can do whatever the heck it wants internally. It could call on other things that do other layers of processing. And then you would still have all of the like key management questions for encryption as usual, but that's always a thing. If you want to have separate ADLs in different places as you're doing a walk, that's a more like, that's not nesting style composition. That's you use one and then it returns, and then you use another and then it returns. So that's a much easier thing to compose in a way, and things don't actually have to really know about each other to compose that way. So that's what happens when you have like a map dealing with a directory, and then another map dealing with another directory, and then something for bringing bytes together for a file. So that's much easier. For trying to stack things on each other, doing a series of transformations in a way that isn't hard-coded within the ADO, I think that we actually don't really have that super specified right now. At least there's no easy, like, no code declarative way to do that sort of thing. I started thinking about this recently, and there's an exploration report with the title of Lenses in the name that came out recently. But this is not at all a finished standard and has no prototypes yet. So this is just like something to think about. We haven't actually had a sufficiently strong call for that kind of composition yet that it's been forced to exist, but maybe it will happen soon. That would be cool.
One thing that's sort of interesting is you mentioned that is like I couldn't think of if it was really necessary because I can't think of any examples for this, but the way in which the WASM ADLs are specified, you don't get to like, the only callback I passed in was the give me a block callback, which means all of the other ADLs from the rest of the universe are like foreign to you, and all of the other codecs or any other like weird logic is foreign to you. Your ADL just like is a thing that takes in some data model stuff and then spits out some other data model stuff a little fancier, in that like it exposes parts of, I guess, like the node interface, because if it didn't do that, it might be really inefficient, right? Like for large bytes or large maps, or in theory, large integers, it could be really inefficient to do that. But in general, like the codecs and all other stuff, I've like avoided implementing the node interface in a lot of places because I'm trying to minimize the number of like cross boundary calls. I do this premature optimization with a little bit of reliability, relying on other people telling me this is a bad idea, and a little bit of intuition that anything that uses CGO and crosses the boundary out of Go land is terrible. But I have not actually measured that.
And potentially dangerous. Calling random C code on your computer. Yeah, bad idea.
Cool.
So
Yeah.
as for like calling WebAssembly and like having it run other WebAssembly to support some lenses or anything like that, again, that as a working spec to make it like practical. I don't have the link on the top of my head, but it is, yeah, it's a working spec to make that feasible. Like there's like the closest support you could have to do that is like doing multi-threading with web workers in the browser. And then you just have a shared array. So things get really messy really quick. Rust makes it easier to deal with that stuff, but yeah, that's like the only way I could think is feasibly possible to get multiple like WebAssembly to work together to decode a single piece.
Yeah, I mean, the good news is that write once, run everywhere has been like the semi-holy grail of people writing software for like 50 years or something. So we can rely on other people doing stuff. We can kind of like piggyback on whatever is working the most at the moment.
All right. Any more comments to this? Because I saw that there is now at least one update in the notes. So I'd like to get the update from Musin.
Thanks. It was a very small update. I'm making slow but steady progress on helping Eric with the incremental update API, and going back and forth. I have some ideas there. So I've captured some notes on the GitHub issue, and I'm gonna continue to work on that. That's it.
Cool. Thanks. So are there any other questions or other things people want to talk about?
Yeah. So Volker, I believe we talked about this a bit, but I do kind of, or this is Rust specific. So trying to figure out what we want to do with dynamic allocations and like stack stuff. Currently there's not a good split between the library. So if you want like dynamically allocated things, then you'd have a feature. And then like the stack stuff would also, or actually no, it's the other way around usually. For the no STD stuff, you have stack allocated, and that's usually behind a feature. But there's some questions as to like interoperability between that. Like, do you have the same type as exposed, or do you have something different? Like, what's the interface like? And kind of how important is getting everything on the stack? Yeah. I guess like a general question of how important like getting Rust to be less allocating. Yeah.
That's a good question. So I can answer from like what happened, kind of what happened in the past. So yeah, it was always a problem to find people to work on Rust on the multi-format stuff and IPLD stuff. And I basically then looked whoever worked on those things to collaborate with them and see where we're going. And so the most recent installment of the what you're mostly referring to, the multi-format stuff like CID and multi-hash and multi-base. And those people really wanted to get Rust like on like smaller systems, I would say. And then of course, like you want to do stack allocation, or at least it's also like if people go crazy about performance, they want to do stack allocations. And I think this is where the current kind of installment of the libraries come from. I'm also not sure like how much it matters, for example, for CIDs, if they are, for example, heap allocated, how much it would actually matter in depending, like it depends on the application. What certainly is a problem is when you do stack allocation is that at least in Rust or in the how we implemented it, things get quite complicated, I would say. Like it's not super intuitive to use anymore. And the risk get quite big. Like if you think about Rust multi-hash, for example, I think it's way more complex and large than it should be. And it's mostly due to this whole stack allocation story. So I think it would be great to also have some allocated alternative. But yeah, as you say, it's like the question is it a separate library? Is it the same library? Is it with features? Is it totally separate? Is it different crates? I don't know. Like we have to figure out. But then again, to conclude kind of what would be that I think it should be bound to some application or like someone using it, because I find it especially hard in Rust to develop something out of the blue. And like from my experience, you don't get the APIs right. And if you have really a use case and some user of it, it might be easier. So I would hope that, yeah, some users where they want to, for example, do heap allocations or have unlimited size CIDs come up, and then we can look into that closer.
So that how does that look from like the FVM side of things? Because it's somewhat related, I think.
Yeah. So yeah. So currently, as I speak about applications, currently one big driver for the Rust IPLD and Rust multi-formats ecosystem is currently the Filecoin virtual machine development, where I'm also involved and work on IPLD. And there, of course, they are quite happy about doing stack allocations and having kind of like fixed size things and buffers and all those things. Especially like if you think about CIDs and multi-hashes, normally they are fixed size, so you like, yeah, it's easy to work with. So I think for them it's important, or at least like it's nice to have. And especially, at least I get the impression that also the people that want to compile Rust into WebAssembly are also quite keen to not using the standard library, which is kind of a separate issue, but kind of connected, because like when you code in Rust, the no standard, no allocation stuff is kind of related. And I think those people want to use IPLD in WASM are quite excited about this and are also kind of like a big driver for doing it this way with the stick allocations.
Yeah, from a WebAssembly standpoint, like avoiding allocations is pretty important. Like you have a fixed page size and allocating, you can't get returned back, and it's, yeah, there is a good implementation, but it's not great.
Yeah. Yeah.
I wonder. So one thing I noticed as I was poking around with the Rust IPLD stuff, and this is probably like something we could discuss, more. I don't know, offline or at another thing. But like, it doesn't quite. And this is where I was sort of getting at with like, what is the IPLD data model? Is like, it uses. It seems to like rely on Serde heavily as like the way in which it defines how things operate. And obviously like the Serde data model is like not the same as the IPLD data model. It has a whole bunch of extra stuff. It has some stuff that's missing, like CIDs. And sort of how we deal with that. And then like, one that kind of was sort of obvious was like the map strings thing, which hit me into some trouble because Ben code only has strings. There are no bytes. There's just the strings thing. And the strings are sometimes UTF-8 and sometimes they're not UTF-8. In the case of like BitTorrent files, like the pieces thing is just a concatenated list of SHA-1 hashes, which not UTF-8. And then, you have koala.jpg, which is in the name field, which is UTF-8. And so I kind of like V1 of me trying to make this work was I just wrote like a transcoder. I just used like a Serde transcoder that moved the data from, whatever the input codec was to the output codec. Which was nice because there were like there were like Ben code, stuff like already sitting around. But it didn't quite work though because like the data models don't match up. Which is why I sort of went this other way where I was like, okay, I'm not going to try and like build Rust IPLD. Like I don't know enough about how to do this to make that work and make it sane. But I can define like a single codec that seems to map out the data model and I'll just translate into that. It may not be like the optimal format for people who are like actually coding in Rust to actually move stuff around. Like maybe the way things work now is the way to do it. But it was one of those like weird things where it seems like, for instance, like byte map keys are supported under the data model, but I don't think they're supported by any of our codecs if you follow the specs, right? Because the DAG CBOR spec, and maybe it shouldn't because I don't know how many people are following it, but like the DAG CBOR spec says that you're following the CBOR spec and that map keys must be strings. And if map keys are string CBOR strings, then they need to be the text field and then they need to be UTF-8. But that's not, so that just, if the IPLD data model allows for bytes, but like DAG CBOR doesn't, it just means that like DAG CBOR isn't a complete, a complete in that definition IPLD data model representation, as opposed to the IPLD data model representation should be different. Although I am slightly curious as to like, I've heard rumors of the various horrendous things people are doing that are non-spec compliant, but I don't know what they are.
Should I like you started at the Serde stuff, so should I quickly say something about the Serde relation stuff?
Things,
because there is even an issue open somewhere about Serde and IPLD, and from 2 years ago or something, where I said, well, so IPLD and Serde just don't work out because like the data model differences are just like it's just a different data model. And I long fight it for, well, we don't use Serde, and if you look at the current, like what is on GitHub IPLD /libIPLD is not using Serde. But so the new versions that I'm currently working on also for the Falcon virtual machine is using Serde. The reason is that we also inherited a lot of code from ChainSafe's Forest, which is a Falcon implementation, and they use Serde heavily. Also in a pretty bad way. And basically they also had to hack together had it hacked together, working with the data model and so on. And now I've worked with Stephen on those things, and I think I'm now okay using Serde, and we found a hack which is acceptable. But still, yeah, you have this mismatch between the Serde data model and the IPLD data model. It's not ideal. And what you certainly end up with is, which I think is a problem. So my vision with Serde was that, well, if you use Serde, you can use, as I did mention, those transcoders or other formats that like he did. He used an existing one. And those things just won't work automatically. So it means, so I describe it as we use the Serde infrastructure, but not really the codecs. So we use the whole mechanism and how Serde works internally. But if you, for example, want to create your own codec, let's say even you use a popular one, and you want to say you want to represent your IPLD data model as TOML, for example. You can't just plug it in and it would work, but you really need to make changes that it, for example, recognizes the CIDs. And this is really a custom code, and you can't just plug it in. So you really need to fork the library. So that's unfortunate. But on the other side, what we found out working as the IPLD team worked on also codecs for JavaScript and Go, we found out anyway that in the end, we ended up coding our codecs anyway for DAG CBOR and for DAG JSON and so on, and DAG protocol buffers. So as we do it anyway, it's not such a big problem, I would say. But that's just for those people following Rust and so on. It's good to know that you would need to re-implement your codec yourself. Although it's really more like a copy and paste job. So you basically paste in the CID deserializer, which I have coded, and I'm pretty sure you can just really copy and paste it from your DAG CBOR codec, and it works in DAG JSON and somewhere else as well. But yeah, you need to make changes. It's not ideal, but on the good side of things, like Serde is just like, once it works, it's really nice. Like you can just work with your native Rust structures, and you just encode them as IPLD, or you, for example, can now go directly, I think it should work with those transcoders. You can directly go from DAG JSON to DAG CBOR. Of course, internally it has an intermediate step, but like you won't see it, and you basically don't go through an intermediate Rust step, but you kind of like go directly, more or less, from one to another, which is quite nice. And then, of course, like if you think about the vision of IPLD, we have like many formats and so on. You only need to implement your codec once for Serde, and then you can transcode them to all the other ones, and don't need to do basically the N by M thing where you need to code it for everyone. And so this is basically what we get from using Serde, although we have those problems. But I think, yeah. So this is the background about the Serde stuff, kind of. And I haven't talked in this meeting much about the current implementation because I'm still working on replacing the underlying CBOR library for the third time now. And it just doesn't make sense to follow basically because it changes almost every day. So, but hopefully in the near future, we have something that they can then like probably publish and then talk about. And then this will be like the new version of kind of libIPLD where you can then use Serde and work on those things.
I think the Serde CBOR Rust library is deprecated after.
Yes. Yes, and this is the reason why we also switch. Like, it's not but it's one of the reasons. It's also like it's quite old and out. Like, if you read the code, it reads like Rust from 5 years ago. and it's just like also changes how you do things, and it's had many magic numbers and so on. So we switched to another CBOR library called CBOR for II is the name, which we now try to use. And yeah, but more on this once I have a really working version because like if I've talked about it like 3 weeks ago, I've talked about that we use a Ciborium, which we now don't use. So it changes. Yeah. Yeah, and about this whole like map keys, bytes and strings and so on, like this, I mean, we can discuss this for weeks if we want to, which we also have in the past. So yeah, we can't finish this discussion in 5 minutes.
Yeah, I wasn't thinking we were going to finish it in 5 minutes. What I was thinking is, as I was reading through the many very good documents that have been generated on this by folks over the years, I was thinking like there's trying to understand what does it mean when you're trying to make something that is like supposed to be like IPLD data model transitive to some extent, is part of this, or is like one way to talk about the description here. And so I was thinking like there may be some like lessons to learn from here in terms of like where down the rabbit hole we want to go. And it's fair that like there doesn't just I mean, in Go we have two IPLD implementations. One is much newer and shinier than the other, but we do have two. In Rust, I think there were a whole bunch. There's now fewer. Right, and so like every one of those like library sets will sort of follow their own mechanism for what works. But I think especially if you take a look at I think Eric last time showed like a little graphic of like how a lot of the various pieces, whether it's like the codecs or the ADLs, now like some like lens stuff, they all sort of end up exposing an interface that is like the data model. And so having like agreement on like, yep, this is what the data model is. You don't have to have all of it. Some of it might suck. You might be like, no. In the same way you might be like, CBOR seems good. Nah, no tags, no special tags for you. Right? We could be like, yeah, here, this is the IPLD data model, but like, no, you don't want to do this. Okay, fine. Just so that we know like what things are fair game to implement. You know, the example with the map byte keys is like, if map byte keys are not okay, then it also means that they're not, you probably don't want to make them okay for, you know, the ADL or the lens layer, because then things don't quite line up exactly. And if you do, then okay, then you get this power everywhere and you get the trade-offs everywhere. So like understanding a little bit of like what it is people are expecting from that, I think would be useful, and we'll have like a few more examples to talk about.
So not to dwell on it too much, but there's also either was it PAC CBOR or now CBOR LD, or basically embedding a dictionary. So you basically in that dictionary can be a URI or or it could be a tag 42 to IPLD, which it basically like is then, even though you're using bytes or numbers as keys, is that there's a dictionary where you actually go through an algorithm to expand it, to do substitution of, you know, here's key number 1, and here in the dictionary that's embedded, it's actually a pointer to what the full text equivalent would be.
Yeah, so I think that's sort of part of it, is like one reason why I think people have been like a little more like, I don't know what to do with this in the past, is like if we look around at our codecs and like none of them support this thing, it's like we want this to exist because we want it for like for things, you know, whether it's like ADLs or lenses or otherwise, but like in some codecs, but none of the ones that we have right now. Right, it's like a little hard to justify because like the codecs aren't there. Whereas you know, sort of when they are, maybe becomes a little easier to discuss. because the same, like you could make a version of DAG.json that like was able to support more exotic things like binary map keys by being like, yep, you don't get to be keys anymore. You get to use like our magic slash that we use in all sorts of places. And like, yep, we're just appending like a list of tuples to the end of you. You're not a map anymore. It's like you have all the map keys and then you have like, here's all the byte keys, or all the string keys, and then you have all the byte keys. Like that's like one way you could do this. But those only come from once you're like at the data, once you have the data model stuff sort of squared away, where you then get to come and be like, what are useful codecs for there to exist that will help people represent their data, you know, represent or transport their data around.
All right, we are hitting the hour mark. So thanks everyone for attending. And I think like today was like, I think today was really like a quite exciting meeting. Like I learned so many new things and like see so much cool things. So hopefully it will be like this every 2 weeks. So see you all again in 2 weeks then. So goodbye everyone and have a good time. Bye.